All right, we are looking at the second page of our 3.3 notes, and where we're factoring, well, we're graphing quadratics. They're in factored form. Notice this one's standard form. I want you guys to get some practice with factoring. So we're going to change this from standard form to factored form. See, that's required information. So we're going to get our factored form first and go from there. So in our factored form, we're going to have, let's see, remember our process for factoring quadratics. We do a times c, so in this case 1 times 3. I look for two numbers that have a product of 3 and a sum that's equal to the b value, right? 1 and 3 are going to work for that because 1 plus 3 is 4. I'm going to make a quick box, and if you're in my honors class, you can skip right to the factoring because we talked about how we don't really have to do the box when a is 1. I've got a 1x and a 3x. Find the GCF for the top row, bottom row, first column, second column. Our factors are going to be x plus 1 and x plus 3. All right? So we have our factored form. Direction of opening, we know this one's opening up because A is positive. The vertex, well, since it's already multiplied out in standard form up here as it was given, we could just do h equals negative b over 2a. So I'm going to do that. Negative b over 2a is going to be negative 4 over 2 times 1, which is negative 2. So that's the x-coordinate of our vertex. The y-coordinate of our vertex. We'll get that by plugging x equals negative 2 back into our function, because remember, with every x, we can find a y to go with it by plugging it into the function. So we'll plug into the function. Negative 2 squared. Notice the parentheses, they're important. If you plug that into a calculator without the parentheses, it's going to give you negative 4, but I need positive 4 because negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. And then we're going to add 3. What is that? 4 plus 3 is 7, take away 8 is negative 1. Or 4 take away 8 is negative 4 plus 3 is negative 1. Either way, we get negative 1. So our vertex is negative 2, negative 1. I'm going to put that on my graph. Negative 2, negative 1, and it's opening up from there. Is the vertex a maximum or a minimum? It is a minimum because my parabola is opening upward. Okay. Axis of symmetry. It's going to be the vertical line through the vertex. So x equals negative 2. I'm going to switch colors here really quick. Do a couple of things. Circle up some important information. Vertex. Vertex is a minimum point. Axis of symmetry. I'm going to draw my axis of symmetry. It's a nice little reference line. Vertical line through the vertex. Okay. All right. Let me change back to my blue. Go back to our full screen. The zeros, or the x-intercepts, they're going to happen when y equals 0. In other words, when x plus 1 times x plus 3 equals 0. I need the x values that are going to give me an output of 0. All right, we'll just replace the f of x with a 0. Get this little equation. So when x plus 1 equals 0, subtract a 1, we get x equals negative 1. The other factor is going to equal 0 when x is negative 3. So my zeros are going to be negative 1, 0, my x-intercepts, and negative 3, 0. Okay, remember, big ideas is probably just going to have you list them as the x values. So the negative 1 and the negative 3, they're probably just going to want you to enter the negative 1 and the negative 3. Keep that in mind. All right. we now need to find, let's put them on the graph. That was one of the things, right? Put them on the graph. So mark them on the graph. Notice the axis of symmetry is halfway in between those intercepts. If it's not, we've done something wrong somewhere, right? Y-intercept happens when x is 0. And when x is 0, y is going to equal 3. Plug in 0. You get 0 plus 0 plus 3, which is 3. Okay? Domain is all real numbers. I'm going to use different notation this time, just to keep you guys remembering the interval notation is out there. And the range, I'm going to get that after I finish my graph. So my smallest y value is -2. It's going to go up from there. But I'm going to finish the graph so I can see that it takes everything from -2 and up. All right, so for completeness here, oh, you know what? I think we're almost good. We got one point that we don't have on there yet. Our intercept, our y-intercept, right? 0, 3. I'm going to use the symmetry line, count to the symmetry line. 1 unit, 2 units, 1 unit, 2 units. With 2 units on the other side. All right, we've got that point. And I'm pretty sure if x is 1, we're going to be off the graph, because 1 squared plus 4 times 1 plus 3, that's going to be 8. 1 plus 4 is 5, plus 3 is 8. Right? We'll be off the graph. So this will be enough. We'll draw our graph. When x is 1, we're going to go through y equals 8. He's off our graph, so we're not going to worry about plotting that one. Okay. And I almost missed that point. Let me try that again. Curving a little bit faster. Oh, that's really wobbly. Can't have that. Okay. There's our parabola. And the range is going to be everything greater than, all y values greater than or equal to -1. I hope I didn't say -2. I feel like I did, though. Y is greater than or equal to -1, because our smallest y value is -1, and we get all the y values above that as we follow the graph. In fact, we get all the other y values twice, don't we? So I'm also going to remind you that we have this interval notation for the set of all numbers greater than or equal to 1. And I'm going to circle up my answer pieces. Here's my x-intercepts. There's my y-intercept. Here's my domain. And one of those is sufficient, but I want you to recognize them both. Okay? All right, we're going to move on to the next example. I'll go ahead and go back to full screen. And we're going to do the factored form of the function f of x equals -2x squared plus 12x minus 16. So let's do the factored form. So we have to factor, right? So the first thing we're going to do is we're going to notice we can pull out a -2. See, everybody's even. Well, we have to pull out the a anyway. To get the factored form, we have to pull out the a, whether there's a GCF or not. So you have to factor out the a. So luckily for us, 12 and 16 are both divisible by 2. So we don't have to worry about fractions. No fractions, yay. So factor out the -2. Double check yourself. Does the -2, when I distribute it back through, recreate my original function? It has to. Okay, now we're going to factor the stuff inside the parentheses, this stuff right here. So we do our a times c. We look for two numbers that multiply to create +8 and have a sum of -6. We're going to have a negative and a negative. Yep. -2 and -4 will work. Okay. Keep practicing. It'll get easier. I'm going to do my box method. Again, if you're in my honors class, you can go right to the factored form right now. If you're not, do the box. X squared and 8. Middle term gets split up. Remember, first term gets the first square, last term gets the last square. So the x squared and the 8. The -6x gets split into two pieces. A -2x and a -4x, which will add up to the -6x. Okay, we've GCF of the top row, bottom row, first column, second column. Check your answer. X times x is x squared. x times negative 2 is negative 2x. X times negative 4 is negative 4x, and negative 2 times negative 4 is positive 8. Okay, it works. X squared minus 6x plus 8. So our final factored form, negative 2 times x minus 2 times x minus 4. Direction of opening is going to be down because a is negative, right? A is negative 2 in my original. I'm going to go back to our original. A equals negative 2. Okay. Vertex, or right here, a is negative 2, right? So it opens down. You can look at it either one. It's the same a value. Vertex. There's a couple ways you can do it. If you want, you could put your intercepts on the graph and then find what's halfway in between, or you can do the negative b over 2a. I don't care which, right? Maybe we'll do that halfway thing again. X-intercepts. Let's go down here. X minus 2 equals 0. Gets me x equals positive 2. X minus 4 equals 0. That only happens when x is 4. So my x-intercepts are going to be 2, 0, and 4, 0. Remember, big ideas probably just wants the 2 and the 4, right? Now, if I put those on my graph, 2 and 4, what number's halfway in between? 3, right? So our axis of symmetry would be x equals 3. Okay, if you don't like that method, you've got the standard form. You can do h equals negative b over 2a. Right, we've got options. Options are good. We've got negative 12 divided by negative 4, which is going to be positive 3. So either way we do it, we're going to get that the h value is the same, right? Once you have that, you still have to find the k value. Now you can either use the factored form or you can use the standard form. It doesn't matter. It will get you the same thing. If you want to use the standard form to find the k value, do that. I kind of like the factored form because the numbers are a little smaller, right? But this works too. Oops, I keep wanting to put a parenthesis there and it's not. What is that? 3 squared is 9 times negative 2 is negative 18. 3 times 12 is 36. And then subtract 16. 36 take away 16 is 20. 20 subtract 18 is 2. That's a 2. Okay, if we put it in the factored form, we would have, let me check it, negative 2 times, let's see. If we take 3 take away 2, we have 1. 3 take away 4 is negative 1. We would still get positive 2. Okay, any way we do it. So we've got our vertex h is 3, k is 2. 3, 2. Don't get them switched around. That's important. 3, 2. Right, there's our vertex. Okay. Is that vertex a maximum or a minimum point? It is a maximum because our parabola is opening downward. You can see it in the 3 points that we already have on the graph that it's got to be going downward. Okay, so it is a maximum point at our vertex. Maximum at the vertex. Axis of symmetry is x equals 3. Vertical line through the vertex, right? And I'm going to go ahead and change colors and draw that axis of symmetry in because I find it very helpful with my graphing. Okay. All right. So got that. We're going to go ahead and we're going to find our, what's the only thing left? We've got the factored form. We know it opens down. We've got a vertex. We've identified the maximum, that it's a maximum point, and that maximum value is a 2. Axis of symmetry, x equals 3. Yep, it's a red line. Notice it's dashed. We dashed that in. 2, 0, and 4, 0 are our x-intercepts. Remember, big ideas is probably going to just want the 2 and the 4 typed in. Y-intercept, oh yeah, we don't have that yet. 0, negative 16. Ugh. I'm not even going to try to put that on the graph because that's way off my graph. Domain is all real numbers. Say it in words or say it with the symbol capital R or say it with the negative infinity infinity that we used last time. And then the range, I'm going to wait so I can see it more easily once I have the graph completed. I am going to do one more x value. I'm going to do x equals 1. Okay, I've got 2, 3, and 4. Let me do x equals 1. So if I plug in x equal 1, I can either plug it into the standard form, factored form. It doesn't really matter. It should come out the same any way I do it. So let's put it in the standard. Negative 2 times 1 squared plus 12 times 1, take away 16. So that's going to be 1 squared is 1 times negative 2. Negative 2 plus 12 is 10. Take away 16 is negative 6. Right? Y equals negative 6 when x equals 1. So we're going to plot the point 1, negative 6. Which is going to be right here. If we were to substitute in x equal 5, we should also find a negative 6, right? Because of that symmetry. I'm going to graph the two halves. Sometimes it's just easier to graph the two halves separately. So there's one of them. Okay. I'm not super happy with that. It's a little wobbly, so I'm going to change it a little bit. But notice it's a smooth curve. We're making it nice and smooth. It's not a super sharp turn. There's half of it. Keeps going down. We don't want to stop at the dot because that would mean it didn't go forever. So we're going to continue it down. And then the right half is there. And there's our graph. We need to fill in the range though yet. The range is all y values from 2 and below. So less than or equal to 2. We've got y values that are less or equal to 2. Okay? Y is less or equal to 2. If you wanted interval notation, we would have to go negative infinity to 2 if you need the interval notation. Okay? This would be fine right there. And we've answered all the questions. Done.